We are moving on to chapter 3 now, and this chapter is called Numbers in the Real World. And in particular, this section is all about percentages, ways to use them, 3 different ways to use them, and then a couple ways that they can be abused. So starting off, we're going to look at the 3 primary ways that percentages are used. Now, this one is the most familiar when percentages are used as fractions. An example would be if you see something that says a total of 13,000 newspaper employees, or 2.6% of the entire newspaper workforce lost their job. Now, in this case, the 2.6% is a fraction of all newspaper employees. So this fraction of all employees equals 13,000. That's how many lost their job. Another way that percentages are used is to describe change. So you might read something that says Citigroup stock fell 15% last week to a value of $44.25. Now, I'm not saying explicitly that it's worth 15% of what it was worth last week. I'm saying that it fell 15%, and we'll unpack what that means in just a few minutes. And lastly, they can be used for comparisons. So the advanced battery lasts 125% longer than the standard battery, but it costs 2,000% more. And we'll unpack what that means. So as fractions, to describe change, and for comparisons. This first example is using an example of how percents are used as fractions. So suppose an opinion poll finds that 35% of 1,069 people surveyed said the president is doing a good job. So how many people actually said that? We know that 35% of 1,069. Well, remember what we said in the last couple sections about keywords. Of is a keyword that indicates multiplication. So writing 35% of 1069 means that we're doing 35% multiplied by 1069. But remember, we don't multiply directly when there is a percent. We need to convert that to a decimal. And we convert it by moving the decimal point that is right there 2 places to the left. That's how you convert from a decimal, from a percent to a decimal. So what we're actually doing is 0.35 multiplied by 1069. And if you do the arithmetic, that works out to be 374.15, or we'll round that to about 374. So that means about 374 people said the president is doing a good job. And we rounded to that answer, that 374, so we could have a whole number, because it doesn't really make a lot of sense to say, 0.15 of a person said the president is doing a good job. So we rounded it to the nearest whole number. So that's how you find the percent of something, when percent is being used as a fraction of something. Next is when percents are used to describe change. So there are 2 types of change we're going to talk about, and I encourage you to write down these 2 equations. First of all, we have what's called the absolute change, and that describes the how a value changes from a reference value to a new value. And this is the equation that I will encourage you to write down, or otherwise memorize it when you're solving these problems. Similarly, since I have the highlighter selected, this is the other one. Now we're going to see lots of other equations that look like this. So once you're used to using one type of equation like this, as you'll see later, it's easier to use the other ones. But anyway, the absolute change, like I said, is the new value, and then you subtract off the reference value. So notice we start with the new value. You always start with the new value in these types of things. And then the relative change is when things are percents. It is a fraction that describes the size of the absolute change in comparison to the reference value. And so the relative change is new value minus reference value divided by reference value times 100 to make it a percent. So let's see an example of how that works. So this example is talking about stock prices. During a 6-month period, some made-up company called Lunar Industry, their stock doubled in price from $7 to $14. So the stock doubled. I want to highlight that so I can come back to it. So what we want to do is describe the absolute and relative changes in the stock price. All right. So first, for the absolute change, I've written down what the formula is. It's new value minus reference value. So if it increased from $7 to $14, the new value is $14 minus the reference value. That's what it was before it changed. That's $7. And so the absolute change is just $7. Now, what's the relative change? It's the new value minus reference value over reference value. So this is equal to new value is $14, reference value is $7 over the reference value, which is $7. We multiply it by 100 so that we can turn it into a percent. So this is going to be 14 minus $7 is $7 over $7. Sorry, left my percent sign out. Times 100%. Well, $7 over $7 cancels out. The sevens cancel and the units, the dollars units cancel out, and that just leaves 1. So 1 times 100% is just 100%. So that is the relative change in the stock value. Now, remember when I said notice that it doubled. When something doubles, it increases by 100%. Okay, the relative change is 100%. Here's another example of how percent can be used as a change. Okay, suppose you bought a new laptop 3 years ago for $1,000. So you bought it 3 years ago for $1,000. So that is the reference value or the old value. And today it's worth $300. So that is the new value. So we want to figure out what the absolute change is. Well, the new value is $300. The reference value, or the old value before anything happened, is $700. Excuse me, is $1,000. I got ahead of myself. So 300 minus 1,000 is negative $700. Now that negative sign where the absolute change was negative $700. That negative sign tells us that the computer's current price is worth less than what you paid for it. So to calculate the relative change, new value minus reference value, well, we just did that. That's the same thing as the absolute change. That's $700. The reference value again is $1,000. We multiply by 100% to get a percent. So this is going to be, well, $700, negative $700 over $1,000 is negative 0.7. And then we multiply that by 100% to get negative 70%. So I want you to notice a couple things just about the arithmetic. The dollars cancel with the dollars. Those units are canceling each other out. And then all we're left with is 700 over 1,000, which gives us the 0.7. And let's make sure we don't neglect that negative sign, because again, the negative sign tells us the laptop is worth 70% less than it was worth 3 years ago. And now we're on the third way that percent is used to express a difference. So we have absolute and relative difference. The absolute difference is the actual difference between the compared value and the reference value. Look how similar this equation is to the one we had for absolute and relative change. we have the compared value minus the reference value. And then the relative difference, I'm going to go ahead and highlight this with my highlighters on. Again, these are equations that you should probably write down and know. And then the relative difference describes the size of the absolute difference as a fraction of the reference value. So this is how we can use percents to describe differences. For example, okay, income comparison. So recent data shows that California ranks first among the 50 states in average income at about $68,900 per person, while West Virginia ranked last at $46,600 per person. So two questions to answer. How much lower is income in West Virginia than in California? And I want you to focus and think about that those two words right there, than in. Second question says, how much higher is average income in California than in West Virginia? Answer both questions in absolute and relative terms. So the important thing to notice here is these are two different questions. The first one is we're asking how much lower is West Virginia than in California? The second question says how much higher is California than in West Virginia? So what we'll be thinking about is which one is the reference value and which one is the compared value. Okay, this first problem, the part A, is asking how much lower are incomes in West Virginia than in California? Okay, so what that's saying is California is our frame of reference in this situation. So California's income is our reference value, and we're comparing California incomes to West Virginia income. So West Virginia is the compared value. So the absolute difference is going to be equal to 46,600 minus 68,900. And that's going to equal negative $22,300. And then to calculate the relative difference, it's the compare minus reference over reference. So it's going to be, we already calculated the compared minus the reference, 22,300 divided by 68,900, because that's our reference value, times 100%. When you plug that into your calculator, you're going to see that this is negative 32.4%. So incomes are, the negative tells us that they're lower in West Virginia, and they're 32.4% lower than in California. So the next part of the problem says how much lower in California than in West Virginia. And so this time West Virginia follows than. So we'll use West Virginia income as the reference and California as the compared value. So the absolute difference turns into this. The compared value now is California, and the reference value is West Virginia. So it's 68,900 minus 46,600, which is a difference of 22,300. Now, notice this is the opposite of the other absolute difference. That's not going to hold true when we do the relative difference, which we're going to do right now. The relative difference is the compare value minus the reference value over the reference value times 100%. So plug in all your numbers, and that works out to be negative 47.9%. And I'm just realizing that this is a typo. That negative should not be there. That is a positive. So I apologize for that. That was an error in the PowerPoint. So you might want to go and, if you've downloaded the PowerPoint files and following along, make sure you make that correction right there. That is a positive 47. Actually, let me just make this explicit and just blank this out and write that the answer is about 47. 0.9%. There we go. So average income in California is more than what's in West Virginia by $22,300, or about 47.9%. Okay, next, of versus more than or less than. This is a super important idea that I want you to write down somewhere, wherever you're taking notes. Okay? P% more than translates to 100 plus P% of. I promise you this absolutely will be on the test, the midterm, and on the final. They'll be quizzed. It'll be on the quizzes. It'll be on the homework. Make sure you know how to do these types of problems. P% less than translates to 100 minus P% of the reference value. Okay. In other words, well, I'll tell you what. Let's just do an example. It's the easiest way. Suppose that Carol earns 200% more than William. What is Carol's income as a percentage of William's? How many times larger? How many times as large as William's income is Carol's? So we're going to use the rule that P% more than means 100 plus P% of. So using that rule, since Carol's income is 200% more than, so Carol's income is 200% more than William's, using this property right here, P is going to be equal to 200. So that means Carol's income is 100 plus 200% of Williams. In other words, Carol's income is 300% of Williams. Now, if we convert 300% to a decimal, remember the way to do that, you take the decimal point and move it 2 places to the left. So this is equal to 3. That means that Carol earns 3 times as much as William. Okay? So I want you to think about what this is saying, because at first glance it doesn't seem to make sense. We're saying that Carol earns 200% more than William, but she earns 3 times as much. That's because percent more than translates to 100 plus that P% of. So that's how you do these types of problems. Let's do another example that is a little bit more concrete. So in this example, a store is having a 25% off sale. 25% off. What does that tell you about how the sale price compares to the original price? Okay. Now, 25% off means that it's 25% less than its original price. The reason they phrase things like 25% off is because people read that and they think, oh, I'm only going to pay 25% of what the original price was. It's not the case. 25% less than. This is equivalent to saying 100 minus 25% of. In other words, 75% of. Because remember the rule that P% less than, saying P% less than, what that means is 100 minus P% of. So when something is 25% off or 25% less than, it's 100 minus 25% of, which is just 75% of. So in other words, the sale price is 75% of the original price. And the last example of this section, tax calculations. You buy a shirt, had a price of $21. Local sales tax is 6%. What is your final cost? Well, the final cost is the label price plus 6% of the labeled price. So to figure out how much you're going to pay for it, you do the final cost is equal to, you pay the label price plus 6% more. So it's 106, 100 plus 6% times the label price, which is equal to 106% times $21. That's 1.06 times $21 for a final sale price of $22.26. All right. Now, go ahead and start on the homework, practice through these, and if you have any questions at all, remember we're starting the office hours, virtual office hours this week. So you can show up there or send me an email, and we'll schedule. If I can't answer your question via email, we'll schedule another time to meet. All right. So this is section 3A, and section 3C is also posted, so you can go watch that one too.